Hi and welcome to the channel. Today we are solving a previous year question from UPSC Maths Optional of the year 2021. So it is based on the differential equation. The question is this one. So if we look here, then this given equation is of the form d square y by dx square plus p of x dy by dx plus rx y is equals to rx. Sorry, so this is, let this be qx. Okay, where this px, qx and rx are a function of x. Okay, so 10x minus 3 cos x is my px, and 2 cos, similarly 2 cos y square x is my qx, and cos to the power 4x is my rx. So we are going to solve this equation by changing the independent variable into another independent variable. Independent variable here is x. Let's transform that x into some independent variable z. So what our aim here is, to transform the given equation into some equation of the form which I know how to calculate. So I know how to calculate some equation of the form this one, dz square plus of p dy by dz plus of q of y is equals to r as a function of z. So where p, q are constants, so I know how to calculate this one. I know how to find the homogeneous solution and the particular solution. So we would be going by this. To convert the given equation into this form, what we can do is we can first calculate the value of dy by dx in the form of in the form of dy by dz. So to get that, this can be written as dy by dz times of dz by dx, right? So this is our first equation. Now in the second part, what we need is d2y by dx square as a function of z. So we can write this one as d by dx of dy by dx. So if we substitute the value of dy by dx from the first equation, what we get is this one, dy by dx of dy by dz into dz by dx. So now we will apply the chain rule here. So in the first case we will keep this as constant, and we will get this one, dy by dz into d2z by dx square, right? And in the second case we will keep the second term as constant, so we get dz by dx times of d by dx of dy by dz. So you look here, this term, if we look here, so we can evaluate it as this one. This is dy by dx of some function of z. So apply the chain rule, what we will get here, this will become f dash of z into dz by dx. So this f dash of z is actually d by dz of that f of z. So if we apply this one here, so we get what, this term becomes d by dz, this becomes d2y by dz square times of dz by dx, right? So the overall equation, we sum them up, d square y by dx square is equals to dy by dz times of d2z by dx square plus of dz by dx into this whole square into d square y by dz square. So this is my second equation. So now we are going to substitute this value in our initial equation. This is my first equation, the second equation is down as what, and now we have this equation. So let's copy this one and we will paste it here. Yes, okay. Now let's substitute the given values. What we get here is For d square y by dz square, we have dy by dz into d2z by dx square plus of d square y by dz square into dz by dx का whole square. Okay, for my px I have, let that be px now, we will substitute it later only. What is dy by dx? My dy by dx was dy by dz into dz by dx plus of qx times of y is equals to r of x. So now we have d square z by, sorry, d square y by dz square into dz by dx का whole square plus of dy by dz. Now combine all the terms here. So one term is from here, another term is here. So we have d2z by dx square plus of px times dz by dx plus of qx times y is equals to r of x. So here we get d square y by dz square plus of, we are dividing by this term, so dy by dz times of d square z by dx square plus of px times dz by dx whole divided by dz by dx का whole square plus of y times of qx by dz by dx का whole square is equals to rx by dz by dx का whole square. Okay, now I have to make a call, right? What kind of a call am I talking about? So if you look here at this term qx by dz by dx का whole square, so we have our qx equals to 2 cos square x. So basically the term with y I have here is 2 cos square x by dz by dx का whole square. So I have to make a call. I can take any value of it such that it becomes a constant. So for the sake of simplicity of calculation, let's take it as 2, so that this 2 and 2, this 2 gets cancelled out. So what we get here is dz by dx is equals to cos x, right? You can also take it as minus cos x or cos x, it's your choice. So I am taking it as cos x. So what we get here is z is equals to sin x. Now let's substitute the value of dz by dx and z in the above equation. So what does this term become? The term with dy by dz, this term. Let's calculate this term. Let's call this term to be p. So what is my p? My p is equals to d square z by dx square plus of p of x times of dz by dx whole divided by dz by dx का whole square. So d square z by dx square is what? It is sin x, rather minus of sin x, plus of px is my this one. Let's copy this. 10x minus of 3 cos x is my px. Put it here. Okay, 10x minus of 3 cos x is my px, and that is getting multiplied by dz by dx, and dz by dx is cos x. So this is cos x whole divided by sin x, cos x का whole square. Now let's manipulate this one. Minus of sin x plus of 10x into cos x becomes sin x, minus of 3 cos square x divided by cos square x. So this comes out to be minus 3. Okay, so my p is equals to minus 3, my q is equals to 2. Now let's calculate my r. R as a function of z is equals to the term over here. This is my r, the yellow term, that becomes rx by dz by dx ka whole square. What is our rx? From the initial equation, our rx is cos to the power 4x. So this becomes cos to the power 4x by dz by dx ka whole square. That is cos to the power 4x by dz by dx ka whole square becomes cos square x. That is cos square x, right? Now you look here, we need a function of z. Our r is a function of z, but we have it as a function of x. So to convert it to a function of z, we can use basic trigonometric laws. Our z is equals to sin x. So what cos square x would be? It would be basically 1 minus of z square. Okay, so now we have our equation ready. That equation is d square y by dz square plus of p. Our p is minus of 3, so it is minus 3 times of dy by dz plus 2 times of y is equals to r of z, that is 1 minus of z square. This is our new equation. We will solve this equation. We will find y as a function of z, and then we will substitute z is equals to sin x there. This is our roadmap. Okay, so now let's solve this equation. To find the solution, the homogeneous solution, we will get it as m square minus of 3m plus 2 equals to 0. What is m here? M equals to 1 comma 2. So the homogeneous equation becomes y homogeneous is equals to c1 times of e to the power z plus c2 times of e to the power 2z, right? Now we have to go for the particular solution. So for the particular solution, we will use the differential method. What we have here is y times of d square minus 3d plus 2 is equals to 1 minus of z square, right? So what we get here, yp is equals to 1 by d square minus 3d plus 2 times of 1 minus of z square. So if you look here very closely, we can write it like this: 1 by 2 times of 1 upon 1 plus of d square minus 3d by 2, right? 1 minus z square. Again make a mark here. This is equivalent to saying this: 1 plus of d square minus 3d by 2 ka power minus 1, 1 minus of z square. So now look at this term. Can we expand this term? We know the expansion of 1 plus n to the power minus 1. It is equals to 1 minus of n plus n square minus of n cube and dot dot dot. Okay, so expanding this one, we get it as 1 by 2 times of 1 minus of d square minus 3d by 2 plus of d square minus 3d by 2 ka square minus of d square minus, or rather if you calculate it further, the terms from here, d square minus 3d ka cube and all the terms ahead of that will turn out to be 0. So the terms starting from here will become 0 only. How did I say that? So if you look here, I can take d common over here. So overall equation has d cube times of something, and d cube of 1 minus of z square is equals to 0. So anything above this is 0 only, right? So we are concerned with the value only up till this 1 minus of z square. So let's calculate this one. Okay, so multiplying 1 with 1 minus of z square gives me the same thing, minus of d square minus 3d into 1 minus of z square whole divided by 2 plus of d square minus 3d ka whole square by 4 times 1 minus of z square. By the way, this D is differential equation if you don't know, differential if you don't know, differential operator. So 1 by 2 times of 1 minus of z square minus of this term will become it give you minus 2 plus 6z by 2. Okay, and this term would give you, so this term gives you this, and the last term gives us what? It gives us minus of 9 by 2. So solving this, we get it as 1 by 2 times of, let's just take 2 over all, it becomes 2 minus of 2z square minus plus 2 minus 6z minus of 9. So this becomes 1 by 4 times of, rather minus 1 by 4 times of 2z square plus 6z plus of 5. So the general solution, this is my yp, when my yc was this one, c1 e to the power z plus c2 e to the power 2z. So the general solution, y as a function of z is equals to yc plus yp, and as a function of x we can just substitute the value of z here as what we had, z was, or z was this sin x. Look here, our z is sin x, so we will substitute z equals to sin x here. So our final solution is c1 times of e to the power sin x plus c2 times of e to the power 2 sin x minus 1 by 4 2 sin square x plus 6 sin x plus of 5. This is our overall solution. Thanks for watching.